3. Atlas went silent for 6 hours, then came back different. 107 hours ago, every electromagnetic emission from 3I Atlas ceased simultaneously. The 1420 MHz radio signal that had been transmitting continuously for 3 months stopped. The thermal signature from the vertex domes flatlined. Even the subtle radar reflections changed. For 6 hours and 43 minutes, Atlas was electromagnetically dark. Then everything came back online. But not the same. Signal frequencies shifted, power levels changed, rotation period adjusted by 0.3 seconds. Atlas went through a transition. That's not malfunction. That's reconfiguration. When human spacecraft go silent, it's catastrophic. Power failure, computer crash, communication breakdown. Recovery is uncertain and takes days or weeks if it happens at all. Atlas went silent in a controlled shutdown, maintained perfect orbital stability during blackout, and restarted with modified operational parameters exactly 6 hours and 43 minutes later. That's not failure and recovery, that's planned maintenance. Software update, system reconfiguration, deliberate operational mode change. Before I show you the telemetry data that 23 observatories recorded during the blackout, before I explain why the timing and duration prove intentional shutdown, before I reveal what changed when systems came back online and what those changes tell us about Atlas's mission progression, I need you to understand what going silent means for an active spacecraft. Everything stops transmitting simultaneously. Radio emissions, thermal signatures above baseline, active maneuvering. This requires coordinated shutdown of multiple independent systems. Natural failures don't coordinate, they cascade randomly. Controlled shutdowns follow procedures. In the comments below, tell me this. When a gigawatt-powered spacecraft executes perfect simultaneous system shutdown, maintains stable configuration for exactly 6 hours 43 minutes, then restarts with modified parameters, what's the simpler explanation? Catastrophic failure that miraculously self-repaired with improvements? Or scheduled maintenance window executing planned reconfiguration? Because one requires multiple miracles, and the other requires accepting that someone planned this months ago. Let me start with the timeline because precision matters. The blackout began at the 7th of February, 2026, 3 hours 14 minutes and 22 seconds UTC. I can specify to the second because the 1420 MHz signal we'd been monitoring continuously simply stopped mid-transmission. One moment, pulse signal at normal strength. Next moment, silence. No fade, no degradation, instantaneous cessation. Within 90 seconds, observers noticed other changes. The thermal signature from vertex domes decreased from 5 degrees above average to only 1 degree above average. Not to zero, not to ambient. To a specific lower level, suggesting minimal power state rather than complete shutdown. The radar cross-section changed as Atlas's surface properties modified, more absorptive, less reflective, as if surface materials altered their electromagnetic characteristics. The orbital tracking showed no changes. Atlas maintained its Molniya orbit perfectly. No propulsive maneuvers, no attitude changes. The rotation continued at 7.03-hour period. The 6 deployed secondaries maintained their hexagonal formation. Everything kinematic continued normally. Only electromagnetic emissions and active thermal signatures ceased. For 6 hours and 43 minutes, Atlas was electromagnetically quiet. Then at 9 hours 57 minutes and 35 seconds UTC, transmissions resumed. Again, instantaneous. The radio signal returned, but at a different frequency. Previously 1420.405 MHz. Now 1420.418 MHz. A shift of 13 kHz, small but measurable and deliberate. The thermal signature returned to vertex domes, but now 6 degrees above average instead of 5. 20% increase in waste heat emission. The radar cross-section returned to reflective state, but with different scattering pattern than before. And rotation period, which had been exactly 7.03 hours, was now 7.0283 hours. A decrease of 0.0017 hours, approximately 6.1 seconds per rotation. These are not random variations. These are deliberate modifications to operational parameters. Frequency change, thermal output change, rotation period change. Someone or something adjusted Atlas's configuration during the 6-hour blackout. Now let me address why 6 hours 43 minutes is significant. That's 24,180 seconds. Not 6 hours even, not 6.5 hours. 6 hours, 43 minutes, 13 seconds, if we measure precisely. This is not round number in any human time unit, but it might be significant in whatever time system Atlas uses. If we convert to other possible time bases, interesting patterns emerge. 24,180 seconds is almost exactly 10,000 beats in a decimal time system where day is divided into 100,000 beats instead of 86,400 seconds. It's also close to 1/3 of Atlas's rotation period at 7.03 hours. Specifically, it's 1.028 rotation periods. The duration might also be operationally significant. How long does it take to reconfigure gigawatt-scale systems, to shut down reactors safely, to modify software, to adjust mechanical systems? 6 hours 43 minutes might be the minimum time required for whatever reconfiguration occurred. Not arbitrary, necessary. Let me walk you through what happened to each system during blackout because the details reveal intentionality. The radio transmission stopped cleanly. In communication systems, you don't just turn off transmitter. You complete current transmission, send termination signal, then power down. Otherwise, you leave corrupted data. The fact that signal stopped instantaneously without degradation suggests controlled termination, not failure. The thermal signature decrease to 1 degree above baseline is diagnostic. If reactor shut down completely, temperature would drop to solar equilibrium over hours. If reactor continued at full power, temperature would remain high. 1 degree above baseline suggests reactor at minimal power. Safety mode. Enough to maintain critical systems but not full operational power. This is hot standby, ready to restart quickly when needed. The radar cross-section change during blackout suggests surface reconfiguration. Some materials and structures can alter their electromagnetic properties through applied voltage or temperature change. Metamaterials. Programmable surfaces. If Atlas's hull incorporates such materials, electromagnetic properties could change during maintenance mode. Perhaps to reduce observability. Perhaps to protect systems during reconfiguration. The orbital and rotational stability during blackout is critical evidence against malfunction. When spacecraft fail, attitude control fails. Objects begin tumbling. Orbits drift as random forces accumulate. Atlas maintained perfect 3-axis stabilization and orbital trajectory without any detectable propulsive corrections during 6-hour blackout. This requires either that passive stabilization is extraordinarily good or that low-level systems continued operating even when high-level systems shut down. Now let me address what changed when systems came back online. The frequency shift from 1420.405 to 1420.418 MHz is precisely 13 kHz. This is not drift, this is retune. Communication systems lock to specific frequencies using synthesizers. Changing frequency requires reprogramming. The 13 kHz shift might be deliberate band change, perhaps to avoid interference or to communicate with different receiver. The 1420 MHz band is the hydrogen line, universally significant frequency used in radio, astronomy, and SETI. But within that band, exact frequency can vary. The original 1420.405 MHz might have been optimized for Earth-based receivers. The new 1420.418 MHz might be optimized for different target. HD 3651 perhaps. The shift might indicate change in primary communication target. The thermal increase from 5 degrees to 6 degrees above baseline, a 20% increase, suggests reactor power increased. If waste heat is proportional to power generation, and we previously calculated 1.4 gigawatts continuous power, the new power level is approximately 1.68 gigawatts. That's 280 megawatts additional power generation. What needs an additional 280 megawatts? New systems coming online, sensors activating, propulsion systems warming up, computing load increasing, weapons charging if they exist. Any major system addition requires power. The thermal signature tells us Atlas is now running hotter, consuming more power, doing more work than before blackout. The rotation period changed from 7.03 hours to 7.0283 hours is small but significant. This is 6.1 second decrease per rotation. Over 24 hours, Atlas now completes 3.407 rotations instead of 3.413. Why adjust rotation rate? One possibility: modified observation requirements, different ground track coverage, different sensor integration times. The rotation rate change might optimize data collection for new mission phase. Another possibility: synchronization adjustment. Perhaps Earth's rotation is being tracked more precisely and requires fine-tuning. Or perhaps synchronization target changed from Earth to something else. Let me walk you through system-by-system analysis of what likely occurred during 6-hour shutdown. First, reactor power reduction to hot standby. This requires control rod insertion, reduction of cooling flow, stabilization at low power. Safely done, this takes 30 to 60 minutes. Second, shutdown of non-essential systems. Communications, sensors, secondary power systems, another 15 to 30 minutes. Third, the actual reconfiguration work, software updates, hardware modifications, system tests. If this is what required 6 hours, it's the bulk of the maintenance window. Fourth, reactor power increase to new operating level. This is reverse of shutdown. Withdraw control rods. Increase cooling. Bring systems to critical, then to power. 30 to 60 minutes. Fifth, system restart in sequence. Power distribution, communications, sensors, navigation. Each system verified before next starts. 30 to 60 minutes. Total elapsed time, 6 to 7 hours. The observed 6-7 hour blackout fits perfectly with planned maintenance timeline. Now let me discuss what the secondary objects did during blackout. They continued station keeping, maintained hexagonal formation, but their radio signals also ceased when Atlas went dark. This is fleet-level coordination. When the mothership goes silent, so do deployed units. This is either centralized command where Atlas controls secondaries directly, or distributed protocol where all units follow same maintenance schedule. When systems came back online, the secondaries resumed transmissions simultaneously with Atlas, not randomly, not with delays. Simultaneously, coordinated restart. This level of fleet coordination requires either real-time communication during blackout, using methods we don't detect, or pre-programmed timing where each unit independently knows when to restart. Either option demonstrates sophisticated, autonomous operation. Let me address what observers on Earth experienced during blackout. 23 observatories worldwide were monitoring Atlas when signals ceased. Initial reaction was alarm. Had Atlas failed? Was this catastrophic malfunction? Emergency observation protocols activated. Every available telescope redirected to Atlas. What they observed was puzzling. No debris field, no thermal bloom from explosion, no trajectory changes indicating loss of control. Atlas just continued orbiting silently. After 2 hours, consensus emerged. This was not failure. This was too stable, too controlled. But what was it? By hour 4, speculation centered on maintenance or reconfiguration. By hour 6, observers were waiting for restart, expecting it rather than fearing permanent failure. When signals resumed at 9 hours 57 minutes and 35 seconds UTC, observers immediately noticed the changes. Different frequency, different thermal signature, different rotation rate. Atlas had modified itself. The institutional response was initially public, then suppressed. NASA issued statement after 2 hours, monitoring temporary cessation of signals from interstellar object 3I Atlas. Object remains under observation. After restart, no further statements. European Space Agency similarly went quiet. No explanation of what occurred, no analysis of changes, just silence. I've communicated with colleagues who participated in observation campaign. They confirm all details. Simultaneous shutdown, 6-hour 43-minute duration, modified parameters on restart. But they won't discuss publicly what it means. Off record, clearly planned maintenance. On record, nothing. Now, let me make predictions based on shutdown precedent. First, this was not one-time event. Spacecraft require regular maintenance. If Atlas has maintenance schedule, we should expect future blackouts, possibly on regular intervals. Monitoring for pattern will reveal whether shutdowns occur on schedule. Second, each maintenance window might bring different changes. The first change frequency, thermal output, and rotation rate. Future shutdowns might modify other parameters. Orbital elements, emission patterns, physical configuration. Each change reveals new capabilities or mission phases. Third, shutdown timing might correlate with mission events. The blackout occurred 3 months after Atlas achieved Earth orbit. Perhaps 3-month intervals are maintenance cycle, or perhaps specific mission milestones trigger reconfiguration. Future correlation analysis will reveal pattern. Fourth, if maintenance is planned, there might be preparatory signs. Systems checks, diagnostic transmissions, configuration changes in days before shutdown, monitoring Atlas more closely before predicted future shutdowns might reveal preparation protocols. Let me discuss what changes reveal about mission phase progression. Atlas is not static, it's evolving. Each week brings new behaviors. The blackout and reconfiguration represent deliberate transition from phase A to phase B, from initial observation to something else. The power increase suggests more active operations, more systems running, more data collection, more computation, more communication. This is escalation, increasing activity level, preparing for more intensive operations. The rotation rate adjustment suggests observation target or method changed. New ground coverage. New sensor integration. New operational geometry. The frequency shift suggests communication target changed. Perhaps messages were being sent to Earth-based listeners initially. Now messages go elsewhere, to HD 3651 perhaps, or to other assets we haven't detected. The shift indicates change in communication architecture and possibly change in mission control location. Now let me address what 6-hour blackout means for control and autonomy. If Atlas can shut down for 6 hours, modify configuration, and restart autonomously, it's highly automated. No real-time human control. The round-trip light time to HD 3651 is 72 years. Even if controllers exist there, they cannot intervene on 6-hour timescales. Atlas must have onboard intelligence, artificial or biological, systems capable of executing complex maintenance procedures, diagnosing issues, making decisions, modifying parameters, restarting safely. This is beyond current autonomous spacecraft. Our probes have limited autonomy. Atlas has sophisticated autonomy capable of major reconfiguration without external intervention. The automation also suggests long mission duration. You don't build 6-hour maintenance capability for a 3-month mission. You build it for missions lasting years or decades. Atlas is designed for long-term operation. The maintenance cycles will continue. The reconfigurations will occur, each bringing new capabilities online as mission progresses. Let me walk you through worst-case scenario because threat assessment requires it. If Atlas can reconfigure in 6 hours, what configurations are possible? We've seen communication changes, power changes, rotation changes. What else might change that we haven't seen yet? Propulsion mode. Currently, we detect propellantless maneuvering. What if Atlas has multiple propulsion systems? High thrust for rapid maneuvers, high efficiency for long burns, emergency escape capability. A maintenance window could switch between modes, activating systems previously dormant. Weapon systems if they exist. Power draw of 280 megawatts additional could charge directed energy weapons. Railguns, particle beams, lasers. If Atlas has defensive or offensive capability, it might activate during maintenance window. We wouldn't know until it's used. Defensive screens or shields. The radar cross-section changed during blackout. What if Atlas can deploy electromagnetic shields? Deflector screens? Something that protects against attack or detection? The surface property changes might be activation of protective systems. Deployment of additional secondaries. We've seen 6 objects deployed. What if Atlas carries dozens more? A maintenance window could prepare next deployment phase. Opening bays, initializing systems, preparing for launch of additional fleet elements. Each of these scenarios is possible given the capabilities Atlas has demonstrated. We must plan for possibilities, not hope for benign intentions we cannot verify. Atlas has shown it can reconfigure rapidly. We must assume any configuration is achievable. Now let me address what we should have done during blackout. In retrospect, the 6-hour window was opportunity. Atlas was in reduced power state, vulnerable perhaps. This was moment to attempt closer approach. Send probe for physical inspection. Attempt communication with different protocols. But we did nothing. No spacecraft were positioned to take advantage. No emergency response capability existed. We watched passively as Atlas executed maintenance and restarted with improved capabilities. This is strategic failure. When potential threat reduces capability temporarily, that's opportunity for intelligence gathering or neutralization. We let opportunity pass. Going forward, we need rapid response capability. Spacecraft on standby, pre-positioned for quick deployment during any future Atlas blackout. Sensors ready to gather maximum data during vulnerability window. Communication attempts prepared for transmission during restart sequence. Military options evaluated and held ready if needed. The blackout revealed that Atlas operates on timescales we can match. 6 hours is manageable for human response. If we're prepared, if we're organized, if we're willing to act rather than observe. The next blackout, whenever it occurs, must find us ready. The blackout is documented. 6 hours and 43 minutes of electromagnetic silence. 23 observatories confirmed it. Perfect simultaneous shutdown of multiple systems. Stable configuration maintained throughout. Modified parameters on restart. Different frequency. Higher power. Adjusted rotation. This was not failure. This was planned maintenance. Scheduled reconfiguration. Deliberate mission phase transition. Demand that institutions acknowledge what controlled shutdown means. Demand transparency about the changes detected. Demand preparation for future blackouts that will certainly occur. Atlas has maintenance schedule. It has reconfiguration capability. It has autonomous systems capable of major modifications without external command. The 6-hour window was not malfunction. It was procedure. And procedures repeat. Next time Atlas goes dark, it will come back different again. More capable, more active. Further into whatever mission it's executing, we had 6 hours when it was vulnerable. We did nothing. The next opportunity must not be wasted. Stay rational. Stay vigilant. And remember that when something shuts down perfectly, maintains stability flawlessly, and restarts with improvements, it's not broken. It's upgrading. And upgrades make things more capable, not less.